Welcome, everyone. Today, we are exploring a critical topic for any organization adopting artificial intelligence security. We will identify the core security considerations for AI systems, diving deep into application security, data security, and authentication requirements. Let's get started. Welcome to our deep dive into securing generative AI. When we talk about AI security, what exactly do we mean? It is the comprehensive protection of your AI models, the data they access, and the user interactions surrounding them. The basics of a robust AI security posture always come down to three core pillars: data security, application security, and authentication. Why is this so vital right now? Because generative AI doesn't just read data. It reasons over it and generates new content. This introduces entirely new risk vectors, like data leakage through prompts or malicious manipulation. How do we tackle this? We anchor our approach in the responsible AI principle of privacy and security, ensuring that fundamental privacy rights are preserved while defending against bad actors. As we dive deeper, recognize that AI shifts the security paradigm. You aren't just securing a static database anymore. You must actively protect the dynamic prompts flowing into the system and the generated content flowing out. Without these three pillars in place, innovation introduces unacceptable enterprise risk. Let's look at this flowchart, which maps out our security foundation. At the top, we have generative AI security, which serves as the overarching goal. This immediately branches into our three non-negotiable pillars. On the left, data security, which flows directly into encryption and privacy. This ensures your proprietary information remains yours. In the center, we have application security, feeding into threat mitigation and SDL, the security development lifecycle. This is where we protect the actual software infrastructure. On the right, authentication leads to identity and access control, guaranteeing that only the right people are talking to your AI. This diagram is your mental model for this training. Every security challenge you face with Copilot or Azure AI will be solved by strengthening one of these three interconnected nodes. If any one pillar is weak, the entire system is compromised. Before we secure the system, we must understand who is responsible for what. This brings us to the shared responsibility model. What is it? It is a framework that clearly defines the security obligations of the cloud provider Microsoft and you, the customer. The basics are straightforward. Microsoft secures the underlying cloud infrastructure, the physical data centers, and the foundational models. However, you remain responsible for your data, who gets to access it, and the governance of how your employees use the AI. Why do we use this model? Because clarity is the ultimate defense. If you assume Microsoft is managing your internal employee access permissions, you will create a massive security gap. How this applies depends on your deployment. If you buy a SaaS product like Microsoft 365 Copilot, Microsoft handles the vast majority of the backend security. But if you build a custom PaaS solution using Azure AI, the deep dive reality is that you must configure the network restrictions, implement your own role-based access controls, and actively monitor your specific application's telemetry. You must own your side of the shared responsibility line. This visual breaks down the shared responsibility model. From the main node on the left, we split into two distinct paths: Microsoft responsibilities and customer responsibilities. Follow the top path. Microsoft takes on the heavy lifting of securing the cloud infrastructure and the foundation models themselves. You don't have to worry about the physical servers. Now, look at the bottom path. This is your domain. The customer is strictly responsible for data classification, identity and access permissions, and prompt governance. This diagram makes it crystal clear. Microsoft provides a highly secure vault, but you are entirely responsible for deciding what data goes into that vault and exactly who holds the keys to open it. Understanding this split ensures you focus your security budget exactly where it belongs. Let's dive into our first major pillar, data security. What does this mean in the AI era? It means implementing strict measures to protect your enterprise data from unauthorized access or leakage while it is being processed by the AI. The absolute basics require that your data is encrypted at rest in your storage and encrypted in transit when moving from the user to the AI model. Why is data security so critical? Because feeding sensitive customer data or proprietary intellectual property into an unsecured AI could trigger catastrophic regulatory fines and loss of trust. How do we secure it? We utilize tools like Microsoft Purview to apply sensitivity labels to our documents. If a document is labeled top secret, the AI will honor that classification. The most important deep dive concept you must communicate to your board is this: when using enterprise solutions like Microsoft 365 Copilot, Your data remains within your secure tenant boundary. It is strictly isolated. Microsoft does not use your proprietary enterprise data to train the public foundational models. Your data remains yours. Trace the flow of data security on your screen. We start with raw enterprise data at the top, which immediately flows into Microsoft Purview for classification. Purview acts as a checkpoint, applying strict sensitivity labels. The data is then encrypted in transit as it moves securely into the Microsoft 365 Copilot boundary. Inside this boundary, it is encrypted at rest. Now, look closely at the dotted red line pointing to public model training. Notice the strictly blocked barrier. This is the most crucial part of the diagram. It visually guarantees that while your data interacts dynamically with the AI engine to give you answers, it never leaks out to train the public models. Your corporate intellectual property is securely contained within your own encrypted ecosystem at all times. Our next pillar is authentication and access control. What is this? It is the digital checkpoint that verifies exactly who a user is before they can ask the AI a single question. The basics rely heavily on Microsoft Entra ID, which provides secure, centralized user authentication and single sign-on. Why is authentication paramount? Because an AI model is incredibly efficient at finding information. Without authentication, a bad actor or an unauthorized employee could ask the AI to summarize confidential payroll data. How do we stop this? We implement strict role-based access control, or RBC, and enforce multi-factor authentication. The deep dive here centers on how Copilot actually works. Copilot only ever acts on behalf of the authenticated user. It utilizes Microsoft Graph to check permissions in real time. If an employee does not have explicit SharePoint permissions to read a specific HR file, Copilot is physically incapable of retrieving, reading, or summarizing that file for them. The AI rigorously honors your existing security permissions. Let's walk through the sequence diagram to see authentication in action. Step 1. The user attempts to log in and must authenticate identity through Microsoft Entra ID. Step 2. Entra ID verifies the user and issues a secure token. Step 3. The user submits their prompt to the Copilot engine, passing that secure token along. Now, look at Step 4. The critical security junction. Copilot consults Microsoft Graph to verify data permissions using role-based access control. Step 5. Graph only fetches data from enterprise data that this specific user is allowed to see. Steps 6 and 7. The authorized data is returned to Copilot, which generates and delivers a highly secure, permission-trimmed AI response. This step-by-step flow proves that authentication isn't just about logging in, it is an active, continuous shield that dictates exactly what the AI can see and do on a per-user basis. The third pillar is application security. What is app security for AI? It is the process of hardening the AI application layer itself against malicious inputs and adversarial attacks. The basics are rooted in the Security Development Lifecycle, or SDL. We must apply rigorous threat modeling and secure code analysis to the AI infrastructure. Why? Because generative AI introduces a unique threat called a prompt injection attack, or a jailbreak. This is where a bad actor deliberately crafts a prompt designed to trick the AI into ignoring its safety protocols and generating harmful content. How do we mitigate this? We deploy active, real-time defenses like prompt shields, which scan incoming text and immediately block malicious instructions before the model even processes them. For our deep dive, we look at proactive defense. Microsoft uses AI red teaming and open-source tools like Counterfeit to actively simulate cyber attacks against the AI during the development phase. By constantly attacking our own models in a controlled environment, we identify vulnerabilities and patch them long before the application reaches your production environment. Take a look at this application security workflow. We begin on the left with an external user prompt. This prompt must immediately pass through our first line of defense, the prompt shield decision node. If the system detects adversarial intent, like a prompt injection or a jailbreak attempt, the workflow takes the top path, instantly blocking the request and logging an alert highlighted in red. The LLM never even sees the malicious code. However, if the prompt shield determines it is a safe prompt, it takes the bottom path to the LLM. It is then processed via our SDL secured application architecture, ultimately resulting in the generation of a safe output, highlighted in green. This diagram visually demonstrates defense in depth at the application layer, ensuring the model itself is insulated from adversarial manipulation. Beyond stopping hackers, we must ensure the application behaves reliably for normal users. This requires grounding and safe content generation. What is grounding? It is the architectural technique used to ensure the AI generates factual, contextually appropriate responses. The basics involve using Retrieval Augmented Generation, or RAG. RAG connects the AI to your secure enterprise data, forcing it to read your documents before it speaks. Why is this a security consideration? Because an ungrounded model will hallucinate, it will confidently invent facts, which creates massive operational and compliance risks. How do we enforce safety? We combine RAG data retrieval with metaprompts or system messages. The deep dive here is understanding the power of a metaprompt. A metaprompt operates at a much higher privilege level than a standard user prompt. It acts as the absolute law for the AI. You can use a metaprompt to command the AI. You are a financial assistant. You must never offer investment advice. Only summarize the provided documents. Even if a user begs the AI for stock tips, the metaprompt's security boundary cannot be overridden. This diagram illustrates the secure synthesis of information. The central processor is the AI orchestrator. Notice the three distinct inputs feeding into it. On the left, we have the standard user request. From the bottom, we have the RAG retrieval pulling verified enterprise data, ensuring factual grounding. But look at the top input, the metaprompt/system rules. This sits above the user request, injecting unalterable behavioral guardrails into the orchestrator. All three elements are packaged together and sent to the large language model. Because the LLM is constrained by the metaprompt and fed only verified data, it is forced to generate a factual, policy-compliant output. This visual proves that we do not leave AI behavior to chance. We engineer strict, structural compliance directly into the generation pipeline. Our final strategic consideration is that security is never set and forget. You must implement continuous posture management and auditing. What does this mean? It is the ongoing, relentless monitoring of your AI systems to detect vulnerabilities, shadow AI, and policy drift over time. The basics require integrating platforms like Microsoft Defender for Cloud and Microsoft Purview into your AI ecosystem. Why? Because the threat landscape evolves daily, and how your employees use AI will change. How do we stay ahead? We use AI Security Posture Management, or AI SPM. This capability automatically scans your cloud environment to discover generative AI workloads, assesses their security posture, and prioritizes the risks that matter most. For our deep dive, we focus on accountability. Administrators must have full visibility. By integrating with Microsoft Purview and Microsoft Sentinel, you generate comprehensive audit logs. If there is a security incident, your SOC team can look at the logs and see exactly which user prompted the AI, what the prompt was, what backend data was retrieved via RAG, and exactly what the AI generated in response. Let's review the continuous lifecycle of AI Security Posture Management. Starting on the left, you deploy an AI workload. Immediately, Defender AI SPM steps in to discover and assess the deployment for misconfigurations. Next, Purview governance policies are applied to secure the data layer. The system then enters a state of continuous threat detection. When an event occurs, we hit the decision diamond, anomaly detected. If no, normal operations continue, and the event is logged to the audit trail for compliance. If yes, the system alerts the SOC via Microsoft Sentinel for immediate incident response. Notice the dotted arrow looping back to the beginning. This demonstrates that security governance is an iterative, closed-loop process. Every detection refines the assessment, ensuring your AI security hardens and adapts over time. Let's synthesize everything into a highly practical, real-world use case, securing financial automation. Imagine a global financial firm that wants to use generative AI to automate the summarization of complex, highly sensitive client loan agreements. The basics of their problem: they face massive regulatory fines and reputational destruction if client data leaks, or if the AI hallucinates financial terms. Why are the three pillars crucial here? Because to achieve this automation safely, they must implement flawless application, data, and authentication controls. How did they architect the solution? First, authentication. Loan officers must authenticate via Microsoft Entra ID to access the Copilot. Second, data security. All loan agreements are tagged with Microsoft Purview sensitivity labels, ensuring the data is encrypted and cannot be shared externally. Third, application security. They use RAG to strictly ground the model to the specific loan documents and apply a metaprompt instructing the AI to never invent figures. Deep dive result. By orchestrating these layers, the firm achieved 100% verified, compliant summaries, drastically increasing efficiency with zero risk of data leakage. This final sequence diagram beautifully illustrates our secure financial use case in action. We start with the loan officer attempting to log in and request a summary via Enter ID. Once the session is validated, the officer submits a secure prompt to Copilot. Notice that Copilot incorporates prompt shields to ensure the input isn't an attack. Before doing any AI reasoning, the system checks with Purview and Microsoft Graph in Step 4 to verify the document sensitivity and access rights. Once access is granted and the data is securely grounded, Copilot generates the response. Finally, in Step 6, the officer receives a compliant summary. This visual proves that generative AI can operate flawlessly within the most highly regulated environments, provided you engineer the solution with rigorous authentication, strict data security, and active application defenses. Thank you for joining this masterclass on AI security.